All right, we're going to do chapter 12C, motion with variable velocity. Okay, so we use vectors to describe motion, right? But what if the motion doesn't have the same speed? So, like, what if there's a change in velocity? So velocity can be we learned in calculus that velocity can be represented by dr dt, and acceleration can be the second derivative of that. So, as you know, vectors have an x component and a y component. So, my derivative can have an x component and a y component uh, if I break up my motion into x and y values and that are also changing. So you can read this uh, initial part on your own, but let's look at example 3. So a particle has this velocity where the x component is this and the y component is this. So find the speed of the particle when t equals 3. So question A is relatively simple. Um, so when t equals 3, my velocity is going to, we're just going to plug in 3 in for t. It's very simple. And so if I've plugged in 3 in place of t, then it simplifies to 6i plus 9j, right? 3 times 3 is 9. 4 times 6 is 12, and 12 minus 6 is 6. Okay. Question B says, find the time at which the direction of the movement of the particle is parallel to j. So if it's parallel to j, then the I component has to be 0. Okay. So to show that it's parallel to j, I'm going to make the I component equal to 0. So the I component is 4t minus 6, right? So I'm going to make 4t minus 6 equal to 0. And add 6 on both sides. Divide by 4. So t is equal to 1.5 seconds. Excuse me. Okay, question C. Show that the acceleration of the particle is constant. So, so we know my velocity is equal to 4t minus 6 and 3t. Okay, right? So if I take the derivative of this, we know that velocity is equal to, acceleration. To find acceleration, we take the derivative of this, and the derivative of dt, and oops. So the derivative of 4t minus 6 is going to give me 4, and the derivative of 3t is going to give me 3. So this is how you would show the acceleration is constant. Hence, constant. Okay. Question D. Given that the displacement of the particle when t is 0 is this, find a formula for this displacement at time t. Okay, so displacement, we can use the letter R for placement. So in order to find the displacement, we have to take the antiderivative of 4t minus 6 dt and the antiderivative of negative 3t. Okay? Now, and so the antiderivative of that is equal to, that becomes t squared. 1/2 times that is going to give me 2, and then minus 6t, and then plus c. I'm going to put a little subscript 1 because we're going to have more than one c. And the antiderivative of this is going to be, okay, that becomes t squared, so negative 3 over 2t, and plus c also, but I'm going to say that's c2 because that's our second c. Okay, so, okay, now with this information here, we know when t equals 0, we know that uh, the result is for I, right? That means c. If t is 0, then that means that's 0 and that's 0, and so that means c1 is going to be equal to 4. And since there isn't anything j, then c2 is going to be equal to 0, right? Because if t is 0, then that's going to be go away. And if the result is 4i, that's saying it's 4i plus 0j, right? So c1 is going to be 4, c2 is going to be 0, granted that time is 0 and those things all become 0. So now I've got my resulting displacement is r equals 2t squared minus 6t plus 4, and that's the I component, and then plus negative 3 over 2t squared, and that's my j component. As I said, there's no c2, so we'll just leave it like that. Okay. You might want to hit replay and pause if you needed to hear that example again. Okay. Some of these I might just show my answer key and just walk you through it, but we'll do a couple of them together. Okay. The position of the vector of particle p at time t is equal to this, where r is the measurement in meters and t is in seconds. Find the initial displacement. Okay, so when t equals 0, because that's initial displacement, the location is going to be 4 times 0 plus 2 and 3 times 0 minus 0. So my initial displacement is equal to 2, 0. That is the location at the beginning, and I'm going to put meters here. Okay, find the initial velocity of p. So to find the initial velocity, I have to take the derivative of this numerator here, 4t minus plus 2, and the derivative of this. So this is going to be the derivative of 4t plus 2 is equal to 4, and the derivative of 3t squared minus t is going to be 6t minus 1. the derivative of 3t squared minus t is going to be 6t minus 1. And if it's initial velocity, then um, t will be equal to 0. If it's the initial velocity, we're going to use this vector with t being equal to 0. So then I can say my initial velocity is 4, and if I plug in 0 here, I end up with negative 1. And it's meters per second. Okay. And question C, show that the acceleration of p is constant and find its magnitude. Okay. So showing that it's constant, we're going to take the derivative of again. So dv dt. So the derivative of 4 is going to be 0, and the derivative of 6t minus 1 is going to be 6. Okay? So, and find its magnitude. So magnitude is we take the square root, 0 squared plus 6 squared, and you should be able to tell right away this is the square root of 36, which is equal to 6 meters per second squared. Okay. Okay, let's do some more of these questions. Okay, so a particle moves with a velocity v given this velocity vector. Okay, so sometimes I like to write in this version. So your I component is 4t minus 1, and here we've got 5 minus 2t. So this is my velocity vector here. Okay, given the initial displacement of the particle is 2I minus j from the origin, find the displacement of the particle at time t. So we're trying to find r, displacement, the location, right? So in order to find r, I need to take the antiderivative of my velocity vector. So the antiderivative of 4t minus 1 and the antiderivative of 5 minus 2t. Hit pause if you need to. And so the antiderivative of 4t is going to be 2t squared. The antiderivative of negative 1 is negative t, and then we put plus c1. The antiderivative of 5 is 5t. The antiderivative of negative 2t is going to be negative t squared, and then plus c subscript 2. Okay, hit pause if you need to. So then they've told you at the initial time, that's when t is 0, the displacement is 2I minus j. So that means it's going to be a value of 2 and negative 1 from this information. So that means I'm going to make, so if I make this equal to 0 and this equal to 0, then c1 has to be 2. If I make this equal to 0 and that equals 0, c2 is going to have to be equal to negative 1. Okay, so, and I've replaced c1 and c2 with 2 and negative 1. So this is the displacement of the particle at time t. Hit pause if you need to think about this more. Okay, find the distance of the particle from the origin when t equals 2. So basically I'm going to use this equation and I'm going to replace wherever I have t, and I'm replacing it with 2. And then we simply this simplifies to give me this, and then it says find the distance the particle is at t equals 2. So this is the vector, and to find the distance I have to figure out magnitude. So I take the magnitude of this, so we end up with square root of 8 squared plus 5 squared, which ends up with the square root of 89, which is this. Okay. Okay. A particle moves with acceleration this, and the initial velocity is this. Okay, so initial velocity. So if my particle has this acceleration, then my velocity can be represented. The antiderivative 2 dt and the antiderivative of 1 dt is going to give me 2t plus c1 and t plus c2. And the initial velocity is 2, 3. So initial means we're going to make t equal to 0, and we're going to get the 2, 3. So if t is equal to 0, then c is going to equal to 2, c1 is going to be equal to 2, and c subscript 2 is going to be equal to 3. So now I've got my new velocity vector. Okay, so now find the velocity of p at time t. The initial displacement of p is this. Find the displacement of t. So we have to take the derivative, antiderivative again of this 2t plus 2 and t plus 3. So we take the antiderivative again to get my displacement vector, and so the antiderivative of that is equal to 2t becomes t squared, 2 becomes 2t, t becomes 1/2 t squared, 3 becomes 3t, and I have c subscript 3 and c subscript 4. Okay, and so if t is 0, all of that becomes 0 and 0, so c3 becomes 4, and c4 becomes -1. So now I have my new displacement vector. Okay. Question A. Okay, I guess I gotta have that here. Okay, so the velocity of the charged particle in the magnet field at time t is given with this velocity vector. So find the time at which the particle is moving parallel to vector j. So if it's moving parallel to vector j, then I need to make I equal to 0, just like we did in example 3 on the first page. So if I'm going to make I equal to 0, I have to make 2t minus 1, I have to make that equal to 0, like we did on the first page. So then I add 1 on both sides, divide by 2, and t is going to equal to 0.5. Question B. Find the velocity of the particle when t equals 2, hence the angle of its direction with vector I. Okay, so find the velocity of the particle when t equals 2. So I've got plug in 2 in this vector, and we end up with 312. Okay, so we found the velocity when t equals 2 is this. Hence, find the angle and its direction it makes with the vector. Okay, so if this is my vector here, then to figure out the angle, we know in the x direction I'm going 3, and in the y direction I'm going up 12. So, and I want to find this angle that it's making. So I've got the opposite side, and I've got the adjacent side. So if I'm dealing with opposite and adjacent, I'm going to write tangent. So tangent of 12 over 3. And if I plug that into my calculator, we end up with 4. And so the inverse tangent of 4 gives me 76 degrees. Okay. Question C says the initial displacement of the particle is 2I minus 3. So initial displacement means, once again, t equals 0. So here we've got a vector for velocity. So to find a vector for displacement, I have to take the antiderivative of the 2t minus 1 and the antiderivative of the 3t squared. And so the antiderivative of 2t minus 1 gives me the antiderivative of 2t becomes t squared. Antiderivative of negative 1 is negative t, and then plus c subscript 1. And then antiderivative of this is that power of 2 becomes a power of 3, and 1/3 times 3, it's just t cubed. Okay, and now, as we said, the initial displacement is when t equals 0, and the c1 value is going to be 2, and the c2 value is going to be negative 3. So now I just replace this with my new c values, and there is my expression for the particle displacement at time t. Okay. Next question. Okay. During the few seconds after takeoff, an aircraft's acceleration is given with this vector, okay, where the two components represent horizontal and vertical speed. When t equals 1, the velocity of the particle is this. Find an expression of the velocity at time t. Okay, so my acceleration is 6t in the x direction and 2 in the y direction, right? Here's my acceleration. I just copied it down. So if I want to find expression for the velocity, I have to take the antiderivative. So the velocity is equal to the antiderivative of 6t dt, and the antiderivative of this of the y component or vertical component is antiderivative of 2 dt. Antiderivative of 6t becomes 3t squared, and that was a mistake. And the antiderivative of 2 is 2t. Okay, so now when t equals 1, this is our particle. So I'm going to plug in 1 in place of t, and my answer is going to be 7 and 14. So I've plugged in 1 in place of t, and here I end up with 7 and 14. So so then I end up here with 7 equals 3 plus c1. So if I subtract 3 on both sides, I end up with c1 equals 4. And then I have 14 equals 2 plus c2. So subtract 2 on both sides, and I end up with c2 equals 12. And so there's my expression for the velocity. Okay, hit pause if you need to. All right. Now it says find the time at which the direction of the motion of the aircraft is at 45 degrees of the horizontal. Okay, so if it's a 45 degree of the horizontal, that means it's like going that way, right? So if it's going like that, then that means this value and this value is the same number, right? So so if that's the case, then this value and this value have to be the same number, don't they? So I'm going to make 3t squared plus 4. I'm going to make that equal to 2t plus 12. Okay. And now I'm going to bring everything to one side of the equal sign. So subtract 2t on both sides, subtract 12 on both sides, and we get this. And then we say, oh, I can factor this out, and this becomes t minus 2 times 3t plus 4. And so now I know that t either has to be 2 or negative 4/3. But we know that time for the aircraft has to be positive, so we can't have a negative value, and so we know that t has to be equal to 2. All right, let's do our last question. Okay. Okay. So, uh, let's read the question. A particle p has velocity v given with this vector. The initial displacement of p from the origin is this. So initial displacement is when t equals 0, right? Find an expression for the displacement of p at time t. Um, so let's do that first. Okay, this part has to do with part B. Okay, so my velocity is 4t minus 2.5, and then the y component is 3t squared. Okay, so to find displacement, I take the antiderivative of both components there, and so the antiderivative of 4t minus 2.5 gives me, I haven't done it yet, is going to give me 2t squared. The antiderivative of negative 2.5 is negative 2.5t, and then plus c subscript 1. The antiderivative of 3t squared is going to give me t cubed, and then plus c subscript 2. And then we know when time equals 0 that the velocity is going to be this. So I can say that what on earth? Okay, why did I write that down? That was supposed to be 2, 0. Okay, I guess I fixed it here, but not here. Okay. So I'm going to plug in 2, 0 because we know the initial displacement is 2, 0. So I'm going to have 2, 0 equal to this and this. And of course, when t is 0, we end up with c1 equals 2, and c2 is going to equal to 0. Okay, so here is the original guy. And so we have this, because c1 is equal to 2, and c2 is going to be equal to 0, so we don't have anything there. All right, let's answer question B. Question B says, find the expression for its velocity at time t. Okay, so we know the second particle, q, has a constant acceleration at 0, 4. 0, 4. Okay. Its initial velocity is 10 meters per second, and it's parallel to this vector. Okay. So its initial velocity is 0. Sorry. The acceleration is 0, 4, so we want to find the velocity. So I have to take the antiderivative of 0 dt and the antiderivative of 4 dt. And then we get c1 in the numerator and 4t plus c2. This is the velocity vector of q. Okay, so now we know that this is parallel to 3, 4. um, so, but before we can get started, we need to figure out what is the angle, and then because these numbers are just in the direction, but it's not necessarily the correct length because we don't know the scalar yet. But we know that the magnitude is 10. So anyways, let's figure out what the x component and the y component are in terms of angle. So we know that in the x direction it's going over 3, and in the y direction it's going up 4. So here I've got the opposite side and the adjacent side. And I've got opposite and adjacent. I'm going to write tangent of this angle equals 4 over 3. And we know this angle is going to be 53.1. Okay. So I'm going to write out the rest of the steps so that you can see what I'm doing. So in the x direction, we know that this is 10, and we want to find out how, I'm going to call that x, because we want to find out what the x direction of my vector for the velocity is going to be, right? We know it's this direction, but there's some scalar multiplied by it, and we know this length is 10. So next to this angle, this is adjacent, and this here is the hypotenuse. So if I've got hypotenuse and adjacent, and I'm looking at SOHCAHTOA, I'm going to be doing cosine. So I can say cosine of this angle is equal to adjacent over hypotenuse, right? So, but we know the angle is 53.1. So I can say cosine of 53.1 is equal to x over 10. So now if I'm going to solve for this x component, I end up with x equals 10 cosine 53.1 degrees. Okay, and so if I've got my velocity vector, we know the x component is 10 cosine 53.1 degrees. Okay, now we need to figure out the y component. So in the y direction, I'm going to redraw the triangle again. We know that length is 10, and we know that's 53.1 degrees, and we're trying to figure out the y length. If we know that the magnitude is 10, and we know this angle, we can figure out the y length. So if I've got the opposite and the hypotenuse, then I'm going to look at my SOHCAHTOA and use sine, because that's opposite and hypotenuse. So now I can say sine of 53.1 is equal to opposite over hypotenuse, so y over 10. And then if I multiply 10 on both sides, I end up with y equals 10 sine 53.1. And that's my y value here for the my velocity vector. Okay, so now that I've got that, we know that initially let's see, what did I do? Oh, um, okay, I can use my calculator and type in 10 cosine 53.1, and I'm going to get 6, and 10 sine 53.1, and I'm going to get 8. So, um, so when t equals 0, because this is initially, then we know C1 is going to be 6 and C2 is going to be 8. So I go back to this original velocity vector, and now I know that C1 is going to be 6 and C2 is going to be 8, and that gets me this final answer. There you go.